Everyone, my name is Madhav. I am a senior Java developer at Paraguide Technologies. Today, we'll be creating a Java support ticket management system. We are building a traditional client-server architecture-based support ticket management system where you're allowed to create, edit, and delete a support ticket. This application will not use any rich web application frameworks or softwares or libraries such as jQuery, Ajax, or any other technologies. This is a completely traditional client server system. So how we are building it? We will be using Spring Web MVC. MVC stands for Model View Controller. That means an user can only see a view and only connect to a controller. That means when the user sees a view, he can perform an operation on the controller. The controller manipulates the data, or that is the model layer, and the model layer is supposed to update the view again so that the user can see the updated data in the browser. This is a very well known and well established software architecture pattern, and it is being very widely used. So what we'll be using to build this application? We'll be using Spring MVC4, Servlet 3, Jetty 9, Gritty, Maven and Gradle. We'll be using Eclipse Neon 2 to build our system. Jetty 9 is a servlet container which will run our application, whereas Gritty is an embedded servlet container which allows Gradle to run any servlet container such as Tomcat or Jetty inside our application. Maven will be using to manage our dependencies. A Gradle will be using to make sure what dependencies we need and to build file. Without further to do, let's just have a very quick demo of our application. So this is how the support system looks like. So here you can see we have a add new ticket button, an edit button, a delete button, and all the active tickets are being shown over here. So here I have the option to delete a ticket, and once this is done, this ticket is removed from this particular area. I can again go to add new ticket and place a description like, and once it is done, I can click on submit and I can see the ticket has been created. All this has been done using the MVC framework or Spring MVC4. So here the system that you are able to see is the view layer. And whenever I perform some operations such as submit button in add new ticket, it activates a controller class. That controller class then changes the model of our system, and the model pushes the new updated data to the view, and the view gets re-rendered with the updated data. So I can say here 1 2 3 4, and when I click on submit, the same data gets updated over here. So this is how an MVC system works. This is a very basic application, and you would see how we have actually done it. This is how a project structure looks like, where we have our application and we have few folders. So here first of all we will be see the Gradle file. So this build.gradle manifest or specifies what all libraries you need and what all additional plugins we are currently using and how the system should behave when we are creating a war file. So here we are mentioning that for repositories you should always use this class to get some additional libraries that you're using. After you have done that class, we are specifying the Gretty property, such as in which port should it run, what is the contact path should it be, and what sublet container should it use. It is also specifies that what Java JDK we are versioning and what JRE version we are currently adhering to. We are also using Maven local and Maven central library so that all the libraries we have mentioned over the dependencies section gets downloaded in our web inf Java folder. So here you can see we are using GSTL tag and Spring Web Embassy and log back class to log our application. Where this provided compile means at compile time we will be needing Servlet API 2.5, whereas in runtime we don't need that because the servlet containers such as Jetty 9 or Tomcat will have the servlet container inbuilt into them. Again, to run this application or to open this application in Eclipse, we would need what is the context path set for this. So this information is specified over here. Gradle has many more different properties which can be used to define or configure our application, and is available in their website. After that, we would have to have an index file which would get rendered in our application. So this is where the index file lies. After that, we would, in MVC architecture, we have seen we would need model, view, and controller. So this class, this web package, is our controller class. This DO package is our model class, and this service package is our service class. So this controller, this JSP, will talk to this controller class. This controller class will then talk to this service class, and this service class will talk to then DO or data layer class, and the communication will happen. Similarly, this DO will update the service will update the app controller or the controller class, and the controller class will update the index file so that the user can see the updated data. You can see apart from these three packages, we have two more packages such as servlet package and config package. We'll come back to this. So if you have already created any Spring application before or any servlet application before, you would notice that we'll have two files for sure. One file is called as deployment descriptor, that is web.xml, where we specify what servlet container, what servlet architecture we're using, what dispatcher we're using, what is our default context path, what is our default route, and all those stuffs. So with Java Spring MVC4, we can actually remove those XML files and create configuration files in Java class itself. That specific information is written over here. So web.xml is being replaced by servlet Web Initializer class. Similarly, for Spring application, we would need servlet config file or application context file where you will define where the servlet engine or the Spring system should look for its views, its model, its service classes, and controller classes, where it should scope and what is the scoping mechanism for it. The same thing can be replaced with simple configuration file with Spring MVC4. That is why we're using. So we are using annotation based application instead of pure XML based application. This removes the hindrance of managing an XML file. So first of all, we'll like to see how the servlet web initializer works. So in servlet web initializer, if you are able to open this, we can see that the get root config class says that when the configuration has to happen, you should always check for Spring root config class. And wherever any servlet config, like where is the root context and all those stuff, you should always look for Spring config class. And the default context bar of the application is slash. That means with slash, this whenever a slash is being applied in the browser, this config file should decide what servlet container or what servlet engine should be rendered. Now if we go to our Spring root config file, we can see that we need to scan the service classes. That means the Spring root config will actually scan this package for any of your service layer. Similarly, Spring Web Config will look for this particular package, web package, for controller classes. Now in controller classes, we can see if any resources we need, you should be able to fetch from this resources folder, as well as this view resolver, that means in which folder my JSP or JSF file is present should be invoked by this function. So by this way, we are completely removing the XML properties or XML overhead from our application. Now that we have understood how Spring Web Config and Spring Root Config applies, we can move to our MVC pattern. We'll have a different tutorial to understand better how we can actually remove an XML file from a Spring class to annotation based architecture in future tutorials. Now my JSP file, if I go back to my application, can see I have three operations. I have add new ticket, I have a delete ticket, and I have an edit ticket. Now this operation should definitely have three controller methods. So those information is specified over here. So here we can see that we are using our service support system service layer, which will be invoked to our service system, and then we have some request mapping classes. So slash means at initial load what should happen, at add ticket slash add ticket what should happen, and at slash delete what should happen. We have not written the edit functionality over here just for the sake of simplifying this tutorial. Now in Spring MVC 3, we would generally define the service object or bean in our XML or application context itself. Whereas in our application where we are using annotation, we are using the auto-add annotation. This will make sure whenever this application runs, it will automatically auto-add, or that means automatically create the service for our application. That means whenever this app controller gets invoked, this controller will get invoked and it will pass this service layer over here, and that service layer will get injected into this support system object, and bin creation will happen dynamically, so that you don't need to write any of it in your XML file. Similarly, if you have some other service class, you can simply say private final your other service class and then your service method, and the same thing can be initialized over here. In Spring MVC4 or even in Spring MVC3, you have the flexibility to define annotation based auto wiring or annotation based bin creation. So now if you have understood how to create the bin creation by AutoWare, now let's just see how this controller works. So as we know, at default load or at the initial context of application, I should always render the index file. So this index file, that means, should get rendered from over here. That means whenever this slash gets invoked, it will first of all go to view resolver, and with this name it will find out that if I can find any .jsp file. That means if I have said index over here, return index, that means it will go to this view resolver, it will go to this particular folder where I have view JSP, and it will see for if any index.jsp file is available. So whenever I find this index.jsp file, it will directly render that HTML file into, or the JSP file into a browser. Now, how do you pass data from our controller class to our JSP file? That is being done using this model class or this model object. This model object is nothing but model and view object from Spring MVC, which helps us to transfer data from our controller class to our application controller class to our JSP file. So here I am putting model.put tickets, and from my service layer I am getting all active tickets. We'll go back to this all active tickets functionality later, but here we can simply assume that this returns some sort of data, and that some sort of data would be of this parameter, that it will have a ticket ID created by description on what is the current status of the application. This is a simple POJO class. So we are assuming that this particular methods will simply return me a simple list of POJO classes which I can render in the JSP file. So this is one of our DAO config file or DAO class, data access layer class, which defines how the data would look like. Now, once you have displayed all this information in our JSP file, I should be able to add a new ticket. So we have seen in add new ticket, we are passing one parameter called as description. So this description I can add or get in my controller class using this request param object. That means any post parameter I can actually get from this request param object. That means in my post call I have a description field which should be get in my description object of this method. That means in my service class I can call add ticket and who has created this ticket. So for now I have hard coded as admin, and what is the description of the ticket. So this will make sure that this particular ticket with this description gets added in my backend system. And my control class will not determine or will not bother about how this happens in service layer. It will only talk to the view and render back the data to the view. In MVC, this is the best practice, or this is the best benefit out of MVC, where each of the layer does its job separately, and one each other need not know what others are doing and how they are doing it. Now, once I have done this addition of this new ticket, I am supposed to go to my previous page. That means I should be able to see all my tickets that are being added. So this I can be doing in the redirect. That means whenever the system is done, let's redirect the browser to my root config, that is slash. That means whenever add ticket is been performed, it will go back to my this slash view resolver, and then it will render my index file again. So this is how we can redirect in a Spring MVC application. Similarly, for delete ticket, I can say that it adds or needs a query parameter or an additional path parameter set as ticket ID. And ticket ID can be of any string. It's the regex format we can specify here. So you have the flexibility to specify whether it can be string only, whether it can be integer only, or it can be alphanumeric. So here we have mentioned it can be of anything. Now the same path variable I can be accessed via this path variable annotation in Spring MVC. So this path variable will take the ticket ID and put this value in this ticket ID parameter. So similarly, I can call my service layer and I can call this delete ticket method of my service layer to make sure my ticket is deleted. I do not need to bother in my application class how this business logic happens. Similarly, after the ticket deletion is done, I should simply be redirected to my root scope. So this is how my application controller looks like. Now we can see how my index.jsp works with this application controller. So we can see this is pretty much static data and we need not come back to this. So first of all, we are using some Spring MVC tags and as well as JSTL core tags so that I can use that particular information in my JSP file. Similarly, I can say my resources file and in this folder, and I can give a variable to this in my JSP file itself, and I can use that JSP file to load my CSS and JavaScript. This is one way of doing or loading CSS and JavaScript in Spring MVC, and we are currently showing it over here. Instead of doing like this, you can definitely load your CSS or JavaScript from a CDN server, and that should be perfectly fine. So here we have seen at initial load we are supposed to display all the particular tickets that are available. So we know this add new ticket until this part is a complete static information. So we will not go much deep into that. So we are going to see how this particular root or particular information gets displayed in list order. So here you can see in our application controller file, we can see at initial load I am getting this tickets object in my JSP file. The same thing I can use over here. I can do c.forEach. This is a JSTL tag which is nothing but a simple for loop in Java. So I can say c.forEach and the items, meaning what item should it loop through, and I can specify or I can access that particular variable in $curly braces that variable name. That means this variable will get iterated and this all the inside information can actually access this each element of this list of this particular tickets object. And once every element gets enumerated with the current context or current variable or current list item, I had the variable called as tickets. So that I can specify using the var keyword. Now for each element I can access it's created by ticket ID and description with this variable. So here I am accessing the ticket ID by simply specifying $curly braces tickets.ticket ID. Similarly created by description I can put over here. Now I can see that I have a two operation called as delete operation and edit operation. For now we are removing or we are just keeping simply edit button as it is, we are not doing much with it. But for our delete button we are actually creating a form action where the action says delete and then the second argument or the path variable it has is the ticket ID. And then whenever you click on this delete button it will actually invoke this form action tethering to this particular method getting activated. So here you can see the slash delete slash ticket ID is similar to how that action has been done over here. And this is how the delete operation will get performed over here. Similarly for add ticket, I can simply say my this form action means is my add ticket and it has a variable called as description which needs to get passed in my backend. So that information can be specified with the name parameter. That means whatever I specify in this name parameter, my form action will have these variables as my post data and that particular information I can access from my request param annotation in my controller class. So here if you have seen that we have given the name as description so that in my app controller class I can find out the value of this description method. I can say any other name over here. I can say description hello and the same information I should be getting over here and I have to mention it over here like this. So whenever this add ticket operation is done, we're actually doing a post method, and here in delete we're actually doing a get method. So this way in post method we are getting the request parameter, that is post parameter, whereas in get method we are getting the path variable. So this is how the index and app controller connects to each other. Now let's just see how our service layer works. So first of all, let's just go to our get all active tickets class. So here what I am doing, my get all active ticket service layer is actually a service I can specify by this service annotation. Similarly, for controller class I can specify with this @controller annotation, meaning this app controller is actually a controller class. Now in my service layer, I'm actually creating the instance of the DO object. Similarly, I will be able to create an auto-add instance of this particular class, but I have not done that for a specific reason, and I'll come back to this. Now, this get all ticket simply calls a DO layer or model layer, which gets all the ticket and returns to my application controller. This service layer need not bother how this data come from the backend or from the database layer. If I needed to done any sort of business logic on top of this data that I have got from my DO layer, we should have done this in this particular system or in this particular method, and then we would have returned that particular information back to our controller class. But hence we do not need any manipulation of data that is coming from our DO layer to display in our browser. We are not doing any sort of information over here. Similarly, for add ticket, we are just calling the DO add ticket and specifying all the required parameters to create a particular ticket in our DO or business logic or data layer object. So here you can see actually I'm creating or doing a business logic over here where I can say the ticket ID is a random string. So this particular method will create a random string or random integer string, and that will be assigned as a ticket ID. So here you can see the DO layer doesn't bother how the data is generated. It only bothers or takes care of how the data is stored or data is retrieved. Whereas the service layer takes care of how the business logic works and how communication between DAO layer and application layer works. Similarly, for edit ticket, we can do the edit ticket of the DO layer. Similarly, for delete ticket, I'm simply doing DO.delete ticket because I do not have any specific business logic to be done in my service class. But you can definitely add your business logic in your service class, and you're supposed to add your business logic only and only in your service class. Now, let's just go to get all tickets in my DO layer, and I can see like this. So here in my DO layer, so basically we're using a property files to store our particular all each tickets. We are doing it for the simplicity of our video tutorial, and you can definitely exchange or replace this properties file with a database system, and that should work perfectly fine. So now back to the service layer. Imagine we change our application from properties file to a database layer, but still then your service layer need not change anything because it doesn't bother how the data gets retrieved. This is what the most effective benefit of MVC, where your each layer is independent enough to work without the hassle to remember or determine how the other layers works. Now in my system.do flag, actually I'm reading through all my properties file. So here with Java 7 we have try with resource available, where I'm using this data property files to load my property file. Once my property file is loaded, I'm actually enumerating to each of the element that is available in data property file, and I am actually setting to my Pojo class, whereas set ticket ID is my values.0 and all those stuff. So here I am replacing the content or splitting the content hash. That means if I replace this content hash, I'll have three objects. First one is ticket ID, second is who has created this ticket, and third one is the description. The same information I have done it over here, and I am keeping on adding to my list of my data Pojo class. And that Pojo class I'm simply returning back to my service class, and service class returns back to my controller class, and the data is being displayed in our browser. So this entire piece of loading this particular system of data can simply be changed to a database layer, and your application should work just exactly the same way without changing any other part of your code. This is the beauty of MVC pattern. Similarly, for your add ticket class, we are just creating a random set property in a property class so that it adds a new property and saving the property file back again. This is how the add ticket works. Similarly, for delete ticket, we are just removing this particular ticket from a property file and again saving the property file. So this add ticket as well as this delete ticket method can simply adhere or simply include a database layer, and an application should work perfectly fine. So here we have seen how our application, service and app controller works together in MVC, and your application works perfectly fine. So first of all, our app controller talks to our index file or our JSP or JSF file, and then it invokes a service layer. This service layer then invokes our DOL layer, and then the DOL layer takes care of all the data manipulation or data gathering or data addition facility. Here in my support system, I have not auto-wired this particular thing because I just wanted to make sure that you understand this. Spring MVC does nothing but creating an single instance, or like single instance of your only one instance of your DO layer or service layer in your application class, so that multiple objects of your same class doesn't get created. So here the same thing can be replaced with a simple Java object creation, and your Spring application should work perfectly fine. Although it is advised to always create a bin in Spring so that it can determine whether it should reuse an existing memory bin or it should create a new bin. So what we have learned? So you have learned that MVC is a proven pattern and you should always follow it wherever possible. We have also learned how a Spring MVC works with annotation, and we will definitely cover how annotation actually replaces or ties up with normal XML based Spring application. We have also seen how annotation is very useful to create beans and objects instead of XML in our Spring MVC4. So what can be done next? So definitely we can add an edit model to edit a ticket. We can definitely add a database layer to store and retrieve data instead of just to store the data in a properties file. We can actually create a workflow system where you can actually define those support tickets to each person, and then each person can update the status of it. We hope you liked the video and thanks for tuning in. Stay tuned for more latest videos on Spring MVC and Java.